Hello, everyone. In the next session of our program, Building Resilience, Assessing and Managing Environmental Risks, we delve into the importance of valuing climate risks in the real estate market and explore how environmental risk impacts insurance and investment potential. A round of applause for our next panel moderator, Platonas Stylianou, Chartered Civil and Structural Engineer and founding partner at Platonas Stylianou and Associates Civil and Structural Engineers. Platona, the stage is yours.
Thank you so much for inviting us to this very interesting event and this important topic, building resilience, assessing and manage of environmental risk. I think it's a topic of a great interest for everyone, especially for me because we did work on that on the ECE. ECE is the European Council of Civil Engineers that we produce the 3S approach. The 3S is safe, sound and sustainable, which has a lot to do with resilience, with buildings, with hazards and taking account of risk. So I'm very glad to be here with you. We have a very interesting panel of speakers here with us. Michael, which is an architect, and he will introduce himself after a minute. Evangelitsa Tsulovta, the first president of the Cyprus Association of Civil Engineers, the first woman president actually. Marios Georgoudis, which is a civil engineer by profession as well, he will introduce himself. And Alex, our financial expert. So I will just say a few things about the building resilience in general, and then I'll give the floor to our esteemed speakers. So when planning and designing buildings, it is appropriate to try to mitigate the potential of any environmental risk of cost and operational failures by opting to more resilient performance through well-thought investment. It's something that we all have to do, and better planning and better designs. Resilient strategies for buildings should be discussed and implemented as well as with other things, but it should be implemented now so there is a greater chance for increased performance, not only today, but to the future, benefiting all building stakeholders. And when speaking about building resilience, we should all know about the 4R. The 4R robustness, which is the ability to maintain critical operation and functions in face of crisis. Resourcefulness, which is the ability to skillfully prepare and respond and manage to crisis and disruptions. Rapid recovery, the ability to return and constitute normal operation as quickly and efficiently as possible after a disruption. And redundancy, which is proposed as another key feature, which means that all our backup and all resources are supported to the original in case of failure. So that should be considered when planning for resilience. So I will give now the floor to Michael to introduce himself.
Thank you, Platonas. Thank you for inviting us here today. I'm Michael Kosmas. I'm an architect and urban designer by training, and I've been operating in Cyprus for the last 20 years or so. I'm here also very much interested to participate in this discussion as someone who is involved in the workings of the Planning Council of Cyprus, because I think it's very much interesting to see the keyword of sustainability kind of growing to include issues that have to do with resiliency. So are we shifting to questions, or this is an introduction?
No, it's just a brief introduction.
Okay.
We'll go to questions later on. So Evangelitsa, please introduce yourself.
Thank you, Platonas. Thank you for inviting me here. My name is Evangelitsa Tsulovta. I am civil engineer by profession, and I am the president of Cyprus Civil Engineer Association. I am principal labor inspection officer in the Department of Labor Inspection, where I have been working since 1993. And before that, I was involved in structural design and construction sites. So I think that's all about me. Thank you very much.
Thank you, Evangelitsa. So I'll give the floor now to Marios Georgoudis to introduce himself.
Thank you, Platonas. My name is Marios Georgoudis. I'm the general manager at Tech Island. Tech Island is a non-profit organization that is an IT association with more than 300 members. I'm a civil engineer by profession, and I'm currently also a PhD candidate at the Oil and Gas and Energy Engineering of the University of Nicosia. And basically, I'm here today to try to bridge the gap between technology and construction, because unfortunately, construction doesn't move with the speed that technology is running. So there are some emerging technologies that are trying to bridge this gap.
Thank you, Marios. Now, Alex, please introduce yourself. Alex Cernidov is our financial expert.
Yes, my name is Alexander. I'm in construction business for the last 5 years. I'm running a real estate development company. We are making villas, we're making apartments, we're dealing with the office buildings, we're dealing with the listed buildings. So last 5 years I'm facing the, and sometimes struggling with a lot of things which are related to construction. So all the topics what we're discussing now, it goes together with the business and financial models. So it will be very helpful and useful for all developers to go more deep in our discussion. Thank you.
Thanks a lot. I will try to manage the time, so we'll have 10 minutes for Q&A at the end. So if you have any question, please prepare yourself for the last session. So I will start with a basic question for Michael. Michael, as an architect, what do you think is the resilient acceptance and the new trends for resilient building and housing in architecture nowadays?
I think we're witnessing an interesting shift towards properties that are being built as investments, with the investor looking to hold on to the building, and this is kind of coming in to replace the age-old tradition of an institutional client. We've seen many years of developments in private developments in Cyprus that were focused on quick sale. So now with, let's say, this kind of new real estate trends, we're looking at properties from a new perspective. So more investment and more thinking is going into the build-up of resilience. So you want to make your investment last longer. You want it to remain relevant within the market. You appreciate, let's say, potentials in order to kind of change certain uses or certain aspects of it. So all these things have, let's say, a sustainability dimension to it, but they are fueled by the shifts in the real estate, let's say, perspective. From an architectural point of view, I think most architectural practices are, let's say, inspired by this, and more, let's say, thinking and intelligence needs to go and does go into aspects of the building that were of the property that were in, let's say, earlier years that were not looked into. So the layering of systems, the layering of the mechanical, so they can be, let's say, looked at a further stage, or placed, or let's say new technologies that have to do with integration of electronics within structures. Again, to maintain their relevance in the future and keep them, let's say, competitive in the real estate sector in years to come.
Excellent, thank you. I will then like to have your thoughts, because what I heard is very interesting, about short-term and versus long-term resilience planning in architecture. What do you think of that? Each let's say development brings on its own priorities, but I'd like to kind of discuss the planning aspect of your question, because I think there's an interesting dimension that comes through planning, and I'm talking about city planning. And I think one of the reasons that we had, let's say, a short-term perspective
with regards to resiliency in building in Cyprus, because within the real estate culture, the idea of short-term projects has been the norm in the last few decades, and this has been also driven by the planning system. So, if there's an expectancy that the planning system is going to be changing certain parameters, therefore you build for short-term gain rather than long-term gain. So I think, and this is coming from my involvement in the planning system as a vice president of the planning board in Cyprus, I think that the time has come for the country to make certain decisions and kind of stabilize and give long-term perspective to its planning, let's say, agenda.
Yeah, indeed, it's time now for this decision. And as the vice president of the planning board,
I can do my share. Huh?
Yeah. So, Evangelitsa, you are our expert on health and safety. So, can you please give us your perspective of building resilience, consideration during design, but focus on safety?
Thank you, Platonas. Resilience in construction refers to a building's ability to withstand and recover from environmental risk as climate change as well as natural or man-made hazards events. Long-term resilience is about planning for future hazards events and creating an environment where buildings are safe for people to work and to live. Resilience in construction refers also to the industry ability to withstand and recover from the increased risks in the industry and maintain sustainability of the businesses. Building resilience involves all actors having the capacity to prevent, anticipate, and adapt measures to reduce risks. The client, the owner, designers, architects, engineers, contractors, as well as developers and real estate companies. Decisions that we make about a project throughout its planning, design, construction, operation, maintenance, and demolition cycle can help to minimize these risks. These decisions include the location of a project, technical solutions, selection of materials, as well as selection of professionals and skilled personnel involved in various stages of the project. Achieving resilience in the design of new buildings and facilities and the renovation of existing focuses on increasing the robustness of the structures and the ability to achieve the desired performance in response to hazards. To increase resilience and minimize impact from natural and man-made hazards, various aspects should be considered during the design of a building or other structure, and I would like to refer and focus on maintainability and safety. Maintainability has two dimensions to be considered. The one is the ease and cost effectiveness of regular maintenance and the other one is the ability to restore and maintain a system or component after a damaging event. Maintainability is also related to long-term performance and the ability of the building or facility to remain functional over the time. Safety has many dimensions and aspects to be considered. One aspect is the safety of the structure, which depends on the quality of the design, the construction standards applied, as well as on the quality of the materials. Safety of the structure is related to building's ability to withstand and recover from natural disasters, including unpredictable earthquake. And I would like to focus on this because earthquake is unfortunately a high risk in our country. The majority of the existing buildings in Cyprus, as well as in other countries built in the 80s, 70s or earlier, lack modern design and construction standards and techniques, including the requirements for resilience, robustness, seismic safety, and energy efficiency. Specifically, we should take into account that in Cyprus, the first regulation for seismic design has been enforced in 1994. Also, the mandatory supervision of construction by architects and civil engineers has been enforced in 1999. Buildings in Cyprus after 2012 are designed and built according to Eurocode 8 for seismic design. Additional, the lack of maintenance culture and the lack of professionalism culture, as well as weakening parts of the building due to uncontrolled interventions and alterations of structural elements and impact of environmental risk can lead to partial or total collapse of a building. And we have been experienced during the last, let's say, months, and maybe some of you remember the collapse of balconies. And fortunately, we didn't have any victims. Our association, Cyprus Association of Civil Engineers, and the Scientific and Technical Chamber of Cyprus, SEDEC, have been promoting the need to regulate regular inspection of buildings and issuing specific certificates, as well as the need to fund structural and seismic upgrading of buildings combined with energy efficiency upgrading. Furthermore, our association supports and promotes what Platonas said before, the 3S approach. This is a joint declaration of European Council of Civil Engineers, ECHE, and the World Council of Civil Engineers, WCC, of which our association is a member. 3S approach, as we heard before, safe, sound, sustainable, the need for integrated structural seismic upgrade of existing buildings together with energy efficiency improvements. This 3 approach was an initiative launched by ECHE in 2020, and our association, through our representatives here in ECHE, initiated that, and the Platonas was involved in this. And today is a common vision of civil engineers worldwide, aiming to promote holistic approaches to upgrading structures that are aligned with global policies and the goals of the United Nations for sustainable development and for a safe and sustainable world. Another aspect of safety is the safety and health of people, or the occupational safety and health of workers during the usage and operation of the building, which also depends on the quality of the design, as well as whether relevant standards and legal requirements of the final usage have been taken into account during the design of the building. For example, buildings intended to be used as workplaces should be designed into and taking into account the minimum legal requirements for workplaces. Safety is also related to occupational safety and health of the workers involved in the construction of the buildings, as well as of the workers undertaking or involved in regular and in any other maintenance of the systems and components of the building, or future alterations of the building. Prevention of foreseen occupational risk should be taken into and integrated in the design, as well as in the technical specifications. And a safety and health plan has to be prepared during the design stage and included in the design, which is the main prevention document and prevention tool for the construction of the building or the structure, as well as a safety and health file refer to future interventions in the building or structure, including routine and emergency maintenance, as well as any alteration. Incorporating safety consideration during the design phase can lead to a significant reduction of accidents. Studies have shown that when safety is a fundamental concept integrated from the earliest stages, Accidents on construction sites can be reduced by 35% when designed out during design stage, and an additional 20% when designed out during preparation stage. Here, I would like also to say that according to a study conducted by the University of Cyprus in cooperation with the Department of Labor Inspection, the cost of accidents is allocated to the state, to the victim, of course, the people that, let's say, are involved in the accident, but also it is allocated by almost 30% to the employer. So this is important to know. OSH continue to be a large part of construction risk management, and it is direct affecting employees, of course, productivity, business performance, construction sustainability, and resilience. Also, I would like to refer to studies that have shown that investing in OSH is worth for the business. For every €1 investing in OSH, the return is 2.2. So it is worth for the business to invest in OSH. Effective safety management requires collaboration and engagement from all stakeholders, from real estate companies and developers, clients, project leaders, designers, and architects, civil engineers, and other designers involved, coordinators, safety and health coordinators, contractors. Everyone plays a crucial role in promoting safety and prevention culture. Maintaining a holistic view of employee wellness, which is safety and well-being, will help to build a high-performing and resilient workforce, which is also let's say, contributing to a sustainable world. And lastly, ensuring safety and health of workers is a fundamental principle and human right. It is not just a legal obligation, but it is also a moral responsibility. Thank you very much.
Thank you, Evangelitsa. Very well explained. I think with that you covered even my second question, which is the occupational health and safety resilient building construction. It was fully covered. So before I give the floor to Marios, I will just make a small clarification. I was not only involved in the 3S, I claim to be the father of the 3S approach. So just a small clarification. Marios, what is your thought about how digital technologies can enhance the climate resilience of buildings? What is your thought on that?
Yeah, of course, we live in the era of smart buildings, and we hear very often the automations and how technology goes into the buildings. So we see the adoption of emerging digital technologies that disrupt the way that we manage our building. Which basically aims to tackle the weaknesses that the traditional way of building has. There are actually 4 phases at the building resilience. The first phase is the planning and design. We have the second phase, which is the absorb. Then we have the third phase, which is the response, and the fourth phase, which is the adaptation. Of course, the most challenging phase out of this is the first one, because it's actually the proactive building resilience. And why it is challenging? Because it has a conflict that the owner has to invest a significant amount in order to go to this design and planning of the building resilience of his property. And of course, to invest an amount of money means that he reduces his return on investment. How you can tackle this? You can implement or introduce legislation, a modern legislation actually that will be supported by digital data in order to push someone to make a proper design on the life cycle of a building. Now, what are the different emerging technologies that can be used at the different phases? At the planning phase, we have the BIM. The BIM is the building information modeling, which actually it's the modeling of the asset, of the property, that you input the data and you have the simulation on its life cycle. The more advanced version of the BIM, it's the DT. The DT is the digital twin. What is a digital twin? The digital twin is a digital replica of the physical asset, at which you get data from the physical asset, you put the data to the digital one, and you monitor in real time how the building responds to the changes of the data. Then on the more advanced phases, on the respond and the adapt, we have the Internet of Things. The Internet of Things basically enables you to use different digital tools like sensors or UAVs or photogrammetry that you get data from the building. You can even use your smartphone to have this monitoring, and all this gathering of data makes the communication and the more efficient monitoring of the asset. And we have now a very recent trend, the artificial intelligence and the machine learning, which it's traded a lot nowadays, and it will also be discussed during this conference here in many panels, the artificial intelligence, at which basically you have the engineering algorithms, you input the data, and they are simulated by machines. So you have this cycle to get a better monitoring of a building.
Very well, thank you. But how does all these things and these environmental changes affect building? What is your thought on that?
I will put my hat as a PhD candidate and what I found out through my research, because I'm focusing on the marine carbon cycle. There are some facts that are scientifically proved. Before the industrial era, the emissions of CO2 were around 280 parts per million. In 2022, around 200 years after the industrial era, this number went to 420 parts per million. If we take into account that the 50% of the carbonate emissions they stay in the atmosphere, the 25% is taken by the plants and the land, and the other 25% is taken by the sea, it means that this cycle is affected. And how it is affected, we see that during the last 100 years, the average temperature was risen 1.5 degrees. So whoever says that the climate change and the temperature growth, it's a science fiction, it's not, it's a fact. And how this is regulated in the sea, during the last 50 years, the ocean, because of this mitigation of the CO2, has become 30% more acidic. And until the end of the century, it will become 50% more acidic, with all the consequences that it will have to the ocean life. But going back to the buildings, what are the factors that are affecting the buildings due to these environmental changes? More emissions in the atmosphere, it means that we have rain that it's more acidic, that basically has an effect on the buildings and on the materials of the building. The higher temperature and this climate change basically creates more temperature variations, and these temperature variations, they accelerate the deterioration of the building materials. So this climate change and the higher temperatures, they have an immediate effect on the building materials. Then we have more humidity and more moisture in the atmosphere, which basically leads to spaces with poor ventilation, more molds that can cause structural causes at the building. And then, of course, we have some severe weather events. I will not speak about tornadoes because we don't have such thing in Cyprus, but because we are located at an area that has shown a lot of earthquakes, especially in the recent year. We remember the case of Turkey. It's very important to monitor the buildings and make regular inspections to the buildings in order to avoid such incidents. Because unfortunately, the buildings, the earthquake design was introduced as a legislation the last 15 years, if I'm not mistaken. 2004, 20 years. The buildings before that, because there is no regulation in place that you need to make regular inspections, and that is that's something that I was going to comment, that EDEG is trying to force the inspection element in the legislation. It's very important if we want to mitigate the effects of the environmental changes.
Thank you, Marios. Alexander, what do you think is the life cycle and cost-benefit consideration in resilient-based designs?
In general, from what we heard just now from all the experts, all this will affect the life cycle. It will increase the life cycle of construction of the buildings. It will benefit for the cost, let's say, for renovation, for the structural reinforcement, and for all this stuff. Also, our speakers mentioned about the new technology implementation in resilient construction, which is also very important when you monitor all these things. Some of the issues what we mentioned now, it's already regulated by government. For example, the seismic activity when you design the building, and engineers are following it. But for me, it's also very important that all these regulated things will be delivered in time. Let's say not long time ago, the electricity authorities they introduced the program of photovoltaic, and now all the buildings, all the new construction, even if you want to reconnect the electricity, you need to put your photovoltaic for your apartment. This caused a lot of problem in AIC, let's say. Now, if you want to go to connect your electricity, you can spend like 6 months, which you just bring your money to deposit. All this needs to work together. Business, professionals of the industry, and the government. And all together, we can bring a better construction. Yeah, thank you.
Thank you. One final question for you, Alex, is the new technology and implementation. You said a few things before, but what do you think, how they can help a resilient construction industry?
Let's take the reinforcement, let's say, because now you can find the new materials. Before, you just put the metal beams and finish the story. Now you can find the fiber optics, which you can bend the columns. You reduce the space what you're losing. You increase the strength of this. All this brings a lot of benefits to construction. It's pretty simple, but it needs to be used. Yeah.
We all have to think clever about these things. So we have a few minutes for Q&A. If anyone have a question. Thank you. The speaker is coming now.
Good afternoon. From the comments I heard just now, I mean, especially on health and safety, and Mr. Kosmas, you're referring to CDM regulations, as I understand it. European regulations dating back a long time ago. All the points you raised are already established and exist. And I'm just wondering why you don't use those terms, because for me it's quite strange. I'm quite familiar with it, and you've highlighted all the points which are covered by that and also resilience, assessing and managing environmental risks. That's what CDM is, construction design management, and it covers all the aspects which you've done, with exception to the digital, because that part wasn't available at the time.
Yes, so Evangelista, I think it's on your...
Yes, thank you. Yes, why I mentioned this? Because although it is regulated, it is not implemented. And there is a lack, let's say, of including prevention principles during the design stage, and also lack of having, let's say, the needed or the required safety and health level during the construction or during, let's say, the usage of buildings. That's why I mention it. I don't know if you are, let's say, in Cyprus that you work or abroad, but in Cyprus we still need to work on this.
Sorry, it's not unique only to Cyprus. The only place I found in the whole of Europe is actually the UK, where they implement it. The rest of Europe is just not implemented. And I just wondered why that was the case. In the rest of the world also, they don't bother with it. I know it's an added cost, but that cost brings back the benefits and touches on every point that you've all raised, again, with exception to the digital, but there's space within that which can draw that in as well.
It's true, and it's very interesting. We are doing our best in Cyprus to try to implement some of these things. I think we're a step ahead of other countries, but still not UK. But I'm not sure if Angelitsa needs to add something on that.
We have, there is a lack of safety and prevention culture, and we have to work on this. And it happens that, let's say, many professionals and companies that are in the construction industry, although they might be aware of it, they don't follow the legal requirements. And as you said, I talked about this before, that if you invest in occupational safety and health, there is a return. So it is, let's say, wealth for the company, because you invest on your employees, and you invest and increase the productivity, and also the quality of the work.
Exactly, yeah. Thank you, Evangelitsa. Any other question? I have one question for our speaker as well. It's about existing structures, and especially traditional or listed buildings. We are thinking about resilience. So how about reusing and make this building resilient? And this is our big effort that we should do versus the new building. So if I need some time from all of you on that, starting from Michael as the architecture of the team, and then.
I think that's a major challenge. I mean, there's a tremendous amount of stock of buildings that remain mostly active. You know, quite a lot are also not active. But we need to find innovative ways to kind of engage them. We need to, let's say, approach. In some cases, at least with listed buildings, I feel that we need to be more open about their reuse. You know, it's important for a building to remain relevant, and this is what we've been talking about. I mean, resilience also has that dimension to it. So we need to engage the existing stock and look at it in fresh ways. We need to find the legislation tools that allow us to attack multi-ownership buildings and let's say look at their structural issues, look at their reuse issues, the reprogramming, repurposing, let's say, of existing structures, because this has this has been traditionally one of the major, let's say, problems of Cypriot cities, that they're not able to kind of shed, let's say, the problematic stock with its problems and re-engage it into the mechanics of the city. So I think that we really need to focus on this, both from a planning, let's say, point of view and from a construction technology point of view.
Yes, thank you, Michael. Evangelitsa?
Yes, thank you. I agree. I totally agree that we need to keep, let's say, existing buildings, and actually, it is a fundamental principle for sustainability. And we have to try. I mean, all the buildings that can be reused, we have to reuse them and not demolish them.
Exactly. We need an operational building stock.
Yes.
Marios?
Yeah, I totally agree with what Michalis and what Evangelitsa said about this, and also I bring the element of these buildings in the cities, especially the old ones. It's our history, it's our culture, so we need to preserve them, and we need to find ways to, as Evangelitsa said, to use in that way that we keep the history of these buildings continued. But of course, within their strengthening of the buildings and the structural upgrade of them.
Thank you. Alexander?
The time is up, but I will say a few words. I faced several renovations of the old buildings, both listed and old buildings which are not listed yet. And basically it's the same procedure, even from design of civil engineers and from others, from seismic activity. From this, you change the foundation, you reinforce the building, you do the same. The only problem is that government needs to follow that it was done in correct way. This is, but if you follow the rules, everything will be good with this city, with this island.
Thank you all. I think our time is up. Unfortunately, it's such a huge topic, building resilience. It never ends. We could speak for another couple of hours, but thanks a lot. I would like to thank our 4 esteemed speakers. Thank you.